خب سلام به همگی. من احسان قاضیزاده هستم.
Hello.
به زبان فارسی هست. امیدوارم که از این سکشن
Hello, dear colleagues.
تیپی صحبت کنیم که چطور میتونه حالا ارتباطات امروزی ما رو قبل از اینکه ارائه رو شروع کنیم
Hello. Hello, distinguished colleagues. Apologies, we had some difficulties with relay. Because it's a Persian language that had to be translated into Russian and then English. So, before I start, do you recognize this person? Anyone who recognizes this person, please raise your hands. I guess Iranians only. No, there is Iranians probably. No, this is the Dave Taht, a person who has devoted his life to buffer bloat solutions. The new routers that we have today have too much buffer because they have the overload. You have the interface and there's too much traffic, meaning that the traffic becomes a buffer. And then there are the queues that get formed. And as a result, the user will have a lot of and will face a lot of delay. So, and latency. In the EU, as a user, might want to kind of open a video, or if you're talking to someone, then this kind of latency will result in disconnection. So what is the TCP? Let's talk about that first. What kind of problems we have with TCP? What is a multipath TCP and what problem it solves? And we also talk about some key problems with traditional TCP, and also we'll see where in the world they have introduced the MPTC. Now let's take a look of how the TCP worked before. This is the protocol of transport layer protocol, which worked in a safe manner and delivered our data. And it also guaranteed that if data packages got lost somewhere, this protocol makes sure that this lost data package is still delivered. So what we use currently in our browsers is all based on TCP. Here, and the figure, you can recognize probably the way the TCP works. So TCP has some has an initiator. It sends the SYN packages, SYN send packets, and once it's connected, then make sure that the package is received through SYN ACK, and that the receiving party receives the data package. Now let's talk about the performance of the traditional TCP. What are the problems out there? Well, we all live in an era of 5G. On your phones, you might have a lot of information, a lot of fast internet. You can send more than 1 terabyte of data. We currently have 800G transceivers that are used even in the phone, some countries. And then the question is, why in this era, in this area in time, we still need to use the download managers to utilize the internet links? Why the TCP alone cannot hit the capability of 10 Gbps? So why do they have to be the download manager? We will talk about those bottlenecks, and we'll see how multipath helps us. So there is this notion as the memory. And they tell us how to, then we can use this TCP BDP to achieve a high level of capacity and high level of put-through capacity bandwidth. What volume of information does the sender send so that the recipient can confirm that the same volume that has been sent is received? So me as a TCP initiator can send the packet and wait for the recipient to receive the packet. What happens here? Our connection will be very weak because I have to wait for confirmation for every sent packet. So TCP helps us avoid this problem, and it creates this window. You can send your data and without have to wait for the confirmation. In Linux 4 generation, it takes 14 kilobytes. You have to send 14 packets, wait for the confirmation. And we can imagine a similar scenario here. So say there are two servers that are connected by 1 gigabyte link, and there is the latency of 50 milliseconds. And that's, I mean, how long it takes to send one packet to from one server to another. So how can we avoid doing that? I mean, how can we this kind of congestion, and how can I fill in 1 gigabyte through just one connection? This very simple formula. We need to multiply bandwidth by round trip time, and we will have the buffer number BDP. So if we have 1 gigabyte with a 50 millisecond, then ultimately it means that 62.5 megabytes get delayed. So I need to improve my TCP and have 62 plus 5 megabyte to be able to send volume of information by just one packet, but to ultimately send this 1 gigabyte of information between these two servers. There are also other limitations of the traditional TCP. The first one is a single point failure. If you are on your phone, you have Wi-Fi connection, and also you have the LTE. So when you use when you go to a browser and when you talk by phone, the phone gets disconnected and Wi-Fi gets disconnected and gets kind of shifted to LTE. And there are several seconds of delay or disruption. After that, the phone will try to restore the connection so that you could continue kind of using it. The problem is that there is no bandwidth aggregation. Say Wi-Fi has 100 megabits and a mobile data has 300 megabits. So you have to use either mobile data or Wi-Fi data. And as a result, you don't have like cumulative volume of 400. You have only 300 or 100, depending on what you chose. Another aspect is that all TCPs for the devices that have several interfaces is not optimal, is not suitable. So let's look at problem 1, where they create us problems. So the what I mentioned is the single point access. We sometimes we use WhatsApp or we make a FaceTime call, and then we kind of disconnected Wi-Fi. And when Wi-Fi is disconnected, then our connection is disrupted while the phone gets connected to LTE and mobile data. This means that the connection is lost, and that we get nervous and frustrated. In 2023, there was a report showing that 42% of remote workers reported dropped calls due to network issues. So TCP was the reason for those dropped calls. Problem 2 that we mentioned is the loss of the bandwidth, or wasted bandwidth. So say I have a device with Wi-Fi, and I have kind of Wi-Fi combined with LTE. So together, combined, they could give me a good bandwidth, but traditional TCP uses only one path. You cannot, again, kind of add them one to another. And as a result, only 5 MPs can be used, and whereas the 30 Mbps are wasted for that connection, meaning so I have to kind of choose one of the paths. And it may lead to some difficulties, and actually operational difficulties in some devices. Problem number 3, no load balancing that all TCPs used to have. There is no balancing. The data centers in the cloud service, we can see them this more often because TCP uses more links, and one connection cannot use multiple links. And should there be a load, a significant load, they will have to be kind of linked, and the others queue or they wasted until TCP is connected. Now let's talk about the multipath TCP. So an extension to the TCP protocol, such as multipath, is available, and it works as layer 4, and it allows the TCP use several interfaces simultaneously. Well, in other words, multipath TCP fully adapts, and although it's kind of similar to what it used to be, but nevertheless, it slightly improves the work and performance of the TCP as a whole. How multiple TCP work? Well, you can see it here in this example. Say I have a mobile phone that is connected through mobile data and through Wi-Fi.
For instance, I would like to make a call to point B to establish a connection. My device in this case, first of all, can go through either Almaty or Wi-Fi, establish communication, and in continuation of this process, we need to establish yet one more connection, the backup connection with the other IP, for instance. Initially, we get connected via Wi-Fi, then mobile data. So by this means, always use all of the options. If something gets disconnected, the second option remains active, and there will be no delay. Here you can see the same mechanism since first we talked about traditional TCP, how the communication is established. Here we can see the diagram of MP-TCP. Well, basically not major difference. Traditional TCP, you can see when a package is sent, they had a multipass key capable. Basically, this is better communication to point B. And when there is such a possibility, sending SYN plus MP and plus ACT, what this basically means, and a multipass language, this means there is reliable communication, safe communication, secure communication, and stable communication. As you can see in the bottom, we have one more connection option in addition to the previous ones. Some of the key features of MP-TCP, which come as a great help. Number one is, of course, simplest handover, handover or fallover. For instance, one type of connection fails, the other type of connection keeps on working. And as a result, I simply stay connected. Number two, the bandwidth aggregation. It utilizes capacity of multiple paths for higher speed. I basically use the entire throughput capability, entire bandwidth, and there is yet another example. It's called intelligence resource pooling. Basically, distributes data across paths based on their characteristics to optimize performance. Intellectually uses all of the available throughput capacity. And of course, there is point number 4, the congestion control for every pathway. LTE and Wi-Fi can be different connections, different capabilities, but here it controls overload or congestion for each of these. Now let's take a look at the example of the real-time use of MPTCP in real life, regardless of what they say there in the books. For instance, Apple. Apple is one of those companies who is the best, who is one of the first to use any innovations. They were the first ones to introduce MPTCP in FaceTime, Siri, and iCloud. To benefit simplest transition between Wi-Fi and cellular. When you lose your Wi-Fi signal, you get a possibility to immediately use cellular data so that your communication never breaks. And because of the MPTCP on Apple devices, their communication delay is very short. Tesla is also using MPTCP. Tesla makes cars which have a lot of electronics, and this is important. They also use this technology. They basically combined all possible throughput options to allow their vehicles to operate problem-free, to increase the speed of communication of the electronic devices on board. For data center efficiency, you can use MPTCP. This will improve their overall efficiency. For those who are familiar with the topology of the data centers, the work of data centers, there are several pathways of using traditional TCP. As you know, traffic is distributed based on the specific pathways along the specific lines. This may result in the situation that if one link loses, one link is lost, the other cables don't get connected. There might be some overload on one part and lack of load on the other part, idling. So MPTCP resolves this issue. The second peculiar feature of data centers is that Microsoft and Facebook, they use this inside their companies, the capabilities of MPTCP. They seriously improve the speed of operations of their machines and databases. So this increase the effective use of the network channels, load balancing improved, and they feature better failure-free operations. The other examples from the real world, 5G networks, which result in a smooth switching between the base stations in order to allow the end user to feel confident in their communications. Also, satellite communication, which is used in a combined form, and multipass TCC, which is used, MPTCP is used for services specifically communicating to drones in order to prevent the signal loss through critical missions. This is a summary of benefits of MPTCP, comparing MPTCP, the topic of reliability and efficiency, Like we said, traditional TCP, there is a single failure point, unutilized throughput, and lack of balancing for the load. All of the traditional TCP is not capable to utilize the entire throughput capacity. For instance, unite or generate LT and Wi-Fi. MPTCP gives us this opportunity. Topic of efficiency, traditional TCP has no load balancing. In MPTCP, we have the intellectual resource pooling that improves the performance and speed. What are the challenges in the adoption of these technologies? When I use MPTCP, the main thing is the middle box interference. Legacy firewalls, they might misunderstand MPTCP protocols. So firewalls, NATs, load balancers, there is a bias support. What operating systems support this? Linux, iOS, macOS, Windows, and Android. The support is very limited. The use of MPTCP is very limited. And there is also the issue of awareness. Apps can be optimized. Specifically, some of the apps, they don't use MPTCP because there is no need to implement any special codes. Thank you very much. This has been my presentation. Should you have any questions, you can get in touch with me using this email.